Hello everyone. Let's understand what is blockchain and how it works. So, you might have heard about the blockchains when you have heard about the cryptocurrencies or some distributed ledger technology or some decentralized technology solution which is solving the people's problem and making the money transaction over the cross border very fast. So yes, so blockchain is somewhere related to cryptocurrencies, but it is not a cryptocurrency. So blockchain is a technology which actually have the concept of P2P or a distributed ledger shared on a P2P network. So as the name suggests, blockchain is a chain of blocks stored on hundreds or the thousands of computers all across the globe or distributed over a geographical location where in the each copy of the blockchain, since it is being distributed on a thousands of machines, each copy of the blockchain is nothing but a ledger. It is actually a full complete ledger which keeps the copy of all the credit and debit of a digital asset. That digital asset can be a pen, a chair, a virtual number, a coin, or it can be anything. So, whatever you can represent a value can be considered as a digital asset. It can be, let's say, my balance is equal to 30. So, their balance is equal to 30 becomes a digital number or a digital value that is being represented through a number. So, blockchain is a decentralized ledger tracking the digital assets on a P2P network. When we say P2P network, it means a peer to peer decentralized network where all the computers are connected to each other in some way and each computer holds the complete copy of the ledger. The ledger can also be seen as a statement since day zero. So let's say if you open an account on 1st January 2017, then the ledger or the full ledger will keep the track of every balance in and out or credit or debit in your account since day zero. So if you create a balance statement since day zero, that will call a complete ledger. So just imagine that full ledger or the bank account statement is actually copied to thousands of machines at the same time in such a way that each machine can verify the individual transaction without involving other machines and announce whether this is a valid transaction or not. Then you actually somehow made a blockchain. So now the question is then how the block and the chain comes into the picture and how they are actually related and connected. So guys, since in the typical ledger case or in a typical book case, each page contains the lines or the numbers, right? Or each page has the lines. So you can imagine the book as a blockchain where the each page is nothing but a block and each page is connected to each other. You know that all the in the books all the pages are in a particular order. That's why if you somebody temper a particular page or remove the page, it is very easy to identify since there is a number involved in the page. So if you can actually imagine the book as a blockchain, each page which is connected to each other as a block and the line inside the page as a transaction, then you understood the blockchain already. So blockchain is actually a ledger which is storing the credit and debit of each and every single record in such a way that it cannot be tampered by anyone without others noticing it or without letting anyone noticing the changes or tampering, because each blocks and each pages are connected to each other. This will become more clear in the upcoming slides. So if you are not able to understand again, I think you have many queries, so that will help you in the upcoming slides. So that understood, I think you guys have cleared about this blockchain. So let's jump to the next slide. So I think book analogy I have already given. The book is equal to blockchain, the page is equal to block, an entry in the page, or let's say if it's a credit entry or a debit entry, it's called a blockchain transaction. So this is how you can connect. So as you said, as you understood already, that it is easy to detect if the page has been removed or deleted, and it is also easy to arrange the pages or blocks and identify any suspicious activity. And that's why the page numbers are very important in the legal agreement in the MOU, because it is helping the readers to understand if there is a page missing in the entire agreement, because changing or removing a page can change the meaning of the entire agreement. So that is very important for part for the ledger as well. A small removal of a page in the ledger can actually corrupt the whole ledger very easily. So it's simple. Let's say if you have an account statement which has 100 pages, and if somebody remove the page number 65, you can easily identify, because the record will not tally itself. If you will tally every balance since day 0 to page number 100, it is easy to detect. So that's called the blockchain. Now you might be thinking, okay, then how it is helping, why it is actually creating a cryptocurrency. So cryptocurrency is nothing but a digital token defined as a number in the blockchain, as being tracked since day 0. So in case of the Bitcoin, it is just a number which is stored in the blockchain ledger and being tracked since day 0. And since people need that digital number, because there can be only one copy, right? If I have 100 bitcoins and you have 0 and if I transferred 50 bitcoins to you, I can never have 100 again, because the ledger will update and it will remove 50 from my balance and it will add 50 to your balance. So this will actually create a single copy maintained securely. So since everybody needs bitcoin, the bitcoin has gained a value. Otherwise, it is just merely a number stored in the blockchain. So this is how exactly the block looks like. The Genesis block is called day zero block, or the block zero, we call it a Genesis block. This is the block which may contain the balance, or it can be even zero, right? So let's say if the blockchain is not minting new tokens or new balance every single block, then the Genesis block must have some initial balance. Otherwise, there would be no way to introduce the new balance. So as you can see, in the Genesis block, there is a something called nonce, which is nothing but a small string based numbers. Then sign n minus 1. Here the sign n minus 1 means the signature of the previous block. Since this is a Genesis block, we are keeping the signature of the n minus 1 to 0. Now, A has 10 tokens, or let's call it a Bitcoin if you want to understand it through Bitcoin. Otherwise, it's just a token, it's just a number. Let's say A's balance is 10, B's balance is 10, C's balance is 15, D's 5, and E's 22. And in this block, actually, there are three transactions that has been initiated, where A transferred one coin to B transferred three coins to E, and E transferred six coins to D. As you know that these transactions are have happened, then the new block must reflect the balance according to these transactions. So when the new block will be added into the blockchain, and you might have noticed that there is a sign n, which is the signature of this current whole block. So as you can see, the signature of the block number 0 or sign n is being generated by the digest of the full block. So this is just a signature of the full block. So that's why it is called SHA-256. So here SHA-256 called simple hash algorithm 256, which actually crunch the any length of data into a fixed length of unique string. So this way, if any single digit or letter has been tempered in this block, the signature will completely change, and it is not possible to reverse the digest or the signature to the original balance or the original text or original data. So this is a one-way crunching. So this way, actually, this SHA-256 has crunched the entire block into a fixed length of a string, and we are calling it a signature of the block. So next, if the new block has been added, the signature of the previous block will go to the sign n-1 into the new block as a header. The nonce will be created. This nonce will be actually created by the miner. The miner, the person or the computer or the server or the process which will add this new block will actually guess this number and will update the balances of all the addresses. So let's say A has now 9. Since A has transferred one coin to B, so it has A is equal to 9. B has transferred 3, right? But B has also received 1, so it has 8 coin now. Similarly, C, D, and E. And there are only two transactions which are new. So Now the transactions will be affecting the balance of the input and will creating the output which will go here. And here the sign n minus 1 is the signature of the previous block which goes here. Then again the signature of this whole block will be created through this process again, which will again go back to the next block as a header. Here the nonce are the number which is being generated by the miners. These numbers or the nonce should be generated in a particular way. Now the way is called the mining algorithms, or the it depends on the blockchain to blockchain, but in a general sense the nonce should be generated in such a way that this new digest or the new signature of the block should be lesser than the previous block. So if this is larger, then this should be lesser, and this should be lesser, and this should be lesser. So technically this all should be in a decreasing order. So now to calculate this particular nonce, the miner has to give a try. So he has to just guess the nonce, calculate the digest. If it is less than this, it's okay. Otherwise, it will try again. So technically, the miner has to try at least a million times or a trillions of times before coming to this right number. So that's why it's calling it a proof of work. So the miner has to calculate this nonce millions or trillions time, and actually spending some computation power to do it, because calculating a nonce and a digest on a million or trillion times is not very easy, because the computation has to take some efforts and will take some power or energy. So that will makes the proof that this particular block has been added after some work, and since the miner has done some work, he will be rewarded with some coin. That coin is called a rewards. So every miner gets a reward to actually do this. Now, since the new mined coins have the value, the miners are happy and the entire blockchain is happy because the new block has been added and it is safe. Now, this way the blocks can go to 100,000, 200,000, or even a million number of blocks. It depends on the algorithm and the technology, that how frequently the blocks are being added. In Bitcoin blockchain, the average time to add a new block is 10 minutes. In the Ethereum blockchain, adding a new block into the blockchain is actually 15 seconds. So this all depends on the blockchain to blockchain, that how frequently this block can be added. Remember, since there will be 100,000 or 200,000 blocks, changing any block will be very difficult for a hacker, because if he does change, let's say after there are 200,000 blocks, and if you decided to change the 111,000 block because he just felt that it is very beneficial for him to add a balance to his own account, so what he will do is he will temper the block and then he will announce it. But the problem is the whole blockchain will be actually following the longest chain. So people will reject his modification and continue. And if he has to replicate all the blocks which are coming, it is not possible, because the adding a block is a computationally expensive process. That's why it is called a proof of work. That's how the blockchain is being made secure. So we'll talk about this in the upcoming parts, where we'll explain that how the miners exactly calculate this. So I'm sure you guys have understood how the blockchain looks like. So this is the easiest way to understand the blockchain. So as you know that the each block is built on top of the most recent block. So it is very difficult to temper any block without affecting all the upcoming blocks. So this makes all sense, that yes, it makes it very safe and easy, because even if I temper any previous block in a single small bit and they are all connected to the digest, it is not possible for me to avoid the tempering without someone else noticing it. That's a very difficult task. So adding a block is the responsibility of the miner. Remember, a node may or may not be the miner. It is not always necessary that a node which is connected to the blockchain has to be the miner always. So since in case of the public blockchain, it is always intentionally made computationally difficult to add a block, so that miner has to compete among each other to make sure that they get the reward into their wallet and secure the blockchain. Because the more complex the algorithm to add a block would be, the more secure the blockchain would be. That's called a proof of work. They have to prove that they have done some work to add a new block. Otherwise, if adding a block would have been easy, then any hacker would have come and replicate the entire blockchain and say his blockchain is valid, which is technically not possible if the proof of work is involved. Otherwise, the other option can be the proof of stake, where the miners are having a reputation in terms of the number of coins owned, or their brand, or their, the recognition in the market. Based on that, they are allowed to add a block. That's called a proof of stake. So there are many debate which one is better, which one is not. It depends on the cases. So as you know that miners try to guess a number, we call it a nonce, in such a way that if it gets crunched with the most recent block's fingerprint, as you can see in the previous case over here, then it actually generate a new fingerprint which is less than the most recent block. Remember, this is optional. Whether it is less than or greater than the most recent block, it depends on the algorithms to algorithms. It is not always necessary that it has to be less. It takes again time and the computational power to add a new block. As I said that the current reward in the Bitcoin is 12.5 BTC, while in the Ethereum the current reward per block is 5 Ether. So the private blockchain can choose the any other method to add a block. They can even trust the miners using some legal agreements and the contracts. That is also possible. So this is also a very interesting way to actually choose the limited miners. So we can also call it a proof of stake. So now let's create our own definition. Let's not follow some XYZ definition which you will never gonna remember. So since we understand the logic, let's create our own definition. So it's a decentralized database which stores the information in the form of transaction. It can be public or private. It stores data in an immutable way. When I say immutable, it means it is very difficult to tamper, but it is very, very easy to detect. That is called immutability in the blockchain here. Remember, immutability doesn't mean in the blockchain that it will never be tampered by anyone. It is easy, but it will always affect his local copy. If you are not able to affect the entire blockchain or the entire network, then it is not something that is good for you. Again, so because of that, it is highly secure. Data gets recorded via consensus based algorithms. Since the consensus is required before adding a new block or adding in their transactions, so this actually helps secure the entire blockchain without involving any trusted third party or a regulator. It uses cryptography and it generally exists over a peer-to-peer network. So here's our definition. A blockchain is a consensus-based, secure, decentralized, public or private database which stores information immutability over peer-to-peer network. So that's our definition. Pretty simple, right? So here's the summary. So let's summarize what is blockchain. It's a decentralized distributed ledger, a data structure where the data is being stored inside the blocks in the form of transactions. It removes dependency on the trusted third party for recording the data in the blockchain. Since people are actually competing among each other to add a new block for the reward, they do it securely. It is very difficult and almost impossible to affect everyone in the world at the same time. That's why it is called safe. In public blockchain, the more complex algorithms are required to avoid malicious activities. Since each block is built on top of the previous block, again the immutability has been achieved. Again, the meaning of immutability is very difficult to fake or alter a block and very, very easy to detect the tampering. And again, this all exists in the memory of computer. There is no hardware involved, or you say the block is actually a physical block. No, it's a memory. It's computer process running in the hardware computers, right? But again, it's all exists in the processes and the memory. So every participant in the blockchain contains almost the same copy of the blockchain ledger. Almost the last few blocks might be different based on the geographical location and the communication protocol, but the ultimate ledger is actually always the same. Okay guys, so that's it about the blockchain. If you want to check out the more certifications, please check out our website blockchain-council.org, where you can find the more courses. Thank you.